Welcome to Global Science in a nutshell. This topic is about metallic bonding. This is a chemistry topic. We will be looking at metals and how they bond. The first thing we have to know is metals are giant metallic structures. The structures formed within metals are giant, and within metals we have metallic bonding. So the simple terms we have to know are metals. Within metals, of course, we have electrons that are loose because they leave atoms, and they can be within the structure of the metal. So they lose electrons as metals lose electrons to gain noble gas configuration. That is when the metals themselves become cations. And then the electrons that are lost and the cations that are left behind can have an interaction between them, or an attraction. This attraction is what we call the metallic bond. The real definition of a metallic bond is it is the electrostatic attraction between metal cations and delocalized electrons. Those electrons that are freely moving within the structure are called delocalized electrons. And as we can see, this is what happens. We have the cations, we have the delocalized electrons, or sometimes called the sea of electrons, and then the attraction between the two creates what we call the metallic bond. As metals have multiple atoms within them, so they're going to have multiple cations within them, and they will have multiple metallic bonds formed within them. So we say they are giant structures. Examples of metals are sodium as well as magnesium and many more. Now, because metals are giant structures, some properties they have are going to be affected by that. And because metals can have electrons which are delocalized within the structure, the properties of metals can be affected by that as well. The first part is the melting and boiling points. Metals have high boiling and melting points, and this is because they have the multiple or the giant structures with multiple metallic bonds, and these will require high amounts of energy to be broken. Therefore, their boiling and melting points will be high. Metals do conduct electricity because they have the delocalized electrons. When a potential difference is applied, or when you connect to a circuit, the electrons are going to flow within the metallic crystal or the metallic structure. And then metals are malleable. To be malleable means they can be hammered or reshaped. The ability of metals to be reshaped or the ability of metals to be converted into tiny wires depends on this illustration here. As we can see, if this is the structure of metals, imagine they have the cations as well as the electrons in between them. When a force is applied, they could realign themselves like this, or the structure could be changed. However, when the structure is moved, electrons go along with the cations, keeping them held together as if it's glue. The electrons are going to hold the cation structure of the cations that have been reshaped together so that the whole structure doesn't break. Therefore, metals will be able to be reshaped into wires or into other shapes or other structures. So we've come to the end of this topic. Thank you. Until next time.